Speak up? How's that? Okay, then. So I realized how many kits I had built this year from QST magazine articles. Now, let's see here. I push a button here. The QST magazine is a really, really fine resource for hams. Okay. We got lots of, obviously, a lot of articles about antennas. There are some really complex build-it-yourself type things like amplifiers and analyzers. Most of the larger efforts take a lot of time and money, but a lot of them are pretty simple, inexpensive things you can always put together in one evening or weekend for sure. And that's what I'm going to show here in this presentation. Word to the wise, most of the small projects offered in the QST magazine are not kits with detailed instructions and pictures and parts lists and all that kind of stuff. They're very basic. If there's code required to like load an Arduino, it's usually on the QST website. But still, you have to find the parts that may not be listed, or quoted, or sourced. And in doing so, you get to customize your project to use parts that you actually have. The first one I want to talk about is this one. All these magazines are up here for you to look at. January had an interesting one. If you'll remember last weekend at the set, there was the 2-1 machine and the 505 or whatever the other machine was. And you didn't know where the sound came from. You heard the sound by the time you looked up to see the display on the radio, it was gone. This guy had the same problem, but he says he monitors 4 different radios. What this kit does, is that when the squelch is broken on a radio, it turns on an LED associated with that radio and lets it persist for 20 seconds or so, settable. So when you hear somebody on what you might be the repeater or simplex, you just simply look and see which LED's on. You know what radio to go to and how to respond. This is a very simple project. In the upper part, you see that project box, and the heart of this is an Arduino. I didn't know much about the Arduino at all until we started the BitX stuff. It's a really simple, easy to use processor. And usually, like this one, has a built-in programming port. And this is another one where you go online on the QST in-depth web page to get the code. But if you look below the picture on the left, you see a schematic. And that's it. That's all. That's it. That's all you have to build. A handful of wires, some LEDs and resistors, and you are done. So that's what I call a very simple kit. But what you have to do is, of course, get the Arduino, but there you go. It's fairly simple. That was January. In February, there was a nice article about audio oscillators. And for example, if you were making a code practice oscillator with a square wave type chip from a timer or something, it's really harsh. And well, people who like bagpipes might like it, but a pure sine wave is much finer, easier to hear and listen to. Plus, it doesn't require a lot of filtering if you're trying to amplify or send it through a radio or something. So that was February. There's the circuit. This is a very, very classic oscillator circuit. And then because the oscillator doesn't start and stop quickly enough for CW, he added an analog switch. The oscillator keeps running, but the switch opens up only when you're keying down. So that is the audio oscillator CW kit project, and those parts are readily available. And that was that month. Now in March was a fascinating article. There wasn't a whole lot here. Some of the QST articles don't have a whole lot in this realm of easy projects. But there's always a column called hints and kinks. And this one, in this month, he called up an article. There's a letter saying, oh, I built this one that you showed last year, but here's how I made it better and did more. This is a coax tester, and I'm going to build one of these very soon. You can test your coax with a multimeter, but what this thing is doing is putting like 2 or 3 amps through to test the continuity of the coax shield as well as the center conductor, more readily shows up iffy connections. And so I showed, that's the page on the left from October last year. And from this year, a person responded and he built that box showing all kinds of different connectors. He can test all kinds of coax. So I thought that was pretty good. And that was March. In April, and this is ironic, coincidental, ironic. Prior to this album, to this issue coming out, both Doug and I had built RF current meters. I'm really interested in measuring currents, RF currents. Your typical watt meter is just measuring voltage with respect to a supposed 50 ohm load. But if you can measure the voltage and the current, then you can get true power. And so I built this, Doug built one, I think, and then the article came out. And the article shows, let me put it, the article gives a really good explanation about how to wind that tiny toroid. But you see the circuit in the middle there, very, very simple. You just, two SO239 connectors, the sense coil, and he's going to a multimeter. I plan to use my own little 1930s version meter.
How many kWs is it?
Yeah. Well, this actually could probably take one, but I don't think his could. So this is what I built, and there's the coil, there's the meter with soon to be connected. I had the box laying around, I had the meter, I 3D printed the hub for the ferrite. It was a blast. Okay, in May, yeah, that was April. This was a really interesting project. In May, a project came out. In typical power supplies, you have something called a crowbar. A crowbar is actually an SCR that when an overvoltage is sensed, the SCR is made to conduct, which shorts out the power coming out of the power supply. I mean, it's a dead short, and you were hoping that the fuse upstream will pop. But what that crowbar does is keeps high voltage from getting into your radio or other equipment. But this fellow said, hey, it's time for a modern approach, and plus that crowbar may not trigger fast enough. So he discovered a chip, and this chip will allow you to go in line with your device, and if the voltage exceeds a certain limit, it'll just shut off the power to the device. And if the power is reverse polarized, it will prevent power from going through. Because it's using very low loss FETs for the pass transistors, there's very little voltage drop at all, even at higher currents. I'm going to demonstrate that here. Okay, lights. I don't know if you can see this. Well, you can't see this. Yeah, please. Please stand by, and we will lose this beautiful image for a short time. Oh yes, but this will be worth it. There you see the watch, the Weather Channel, the cocktail party. Okay, so over on the left is the fluke meter showing 12.8 volts, and the power supply, 12.28, and the power supply showing 12.2. It's hard to see. Okay, keep your eye on this one. As I turn up the voltage, when I get to a certain point I deemed excessive, it just stopped. Coming out of the power supply, I've got 14.8 volts present, but nothing getting to my radio or whatever. When the voltage goes back to normal, bingo, comes back on. My meter shows 12.83. The power supply says 12.8. There's very, very little pass voltage drop whatsoever. Thank you. Can I have my...
And there's the magic box.
Well, this is the magic box, and this is all jury-rigged, homemade. And I use something called, I'll talk about that. But there it is. It's actually, the pass transistors are pasted to the lid of this box with a thermally conductive epoxy. And here's why. Oh, we'll just wait. Now, here's why. This fellow specified these particular FETs as the pass element. So I was going to build one. And the first thing I noticed that that part that he specified in this year's QST is now obsolete. And I couldn't find it. But I found a version of it, which is in production, but it doesn't have the mounting hole to put it onto your heat sink or mount it. And that's when I started looking and found this thermally conductive epoxy adhesive. It's insulating too. And so I use this, and I've used this to great success now. In many, many places, I have this thermally conductive epoxy. Takes the place of a nut and bolt and that thermal paste. Another thing was this chip that does all this logic is really, really tiny. I mean, very tiny. You see that penny? You see the chip? It's on a carrier board you can buy. He specifies that. He says if there's enough demand, he'll supply that assembly. But I bought 5 of those boards and 5 of those chips, and I wound up with 4 that actually work. I learned, the article tells you about this flux paste you put on, and I learned a lot from that. So to me, that was an excellent learning experience, excellent tool, and I'm going to implement it and put it in more of my projects. Okay, that was May? Yes, that was May. Well, June didn't have too much for me. I'm not interested in the ID-880H, but just to show you that here's a relatively simple way to add GPS reporting to your ID-880H. And there, on the bottom left, is a very simple schematic, just a very few parts, very clearly shown. And there you can see where he put it in a box over there. So you can easily add that to your 880H if you'd like. That was July. Oh, that was June, sorry. I don't know much about the digital modes, JT65, 60, JT9, and Whisper, but I do know that there's a lot of interest in our group with that. And this is a very simple way to implement what they call the Raspberry Pi, another microcontroller which is available in this really fully assembled, ready to go board. Upper right there, you see the various ways you connect it. All you have to do is use a few cables and you're done. So I just showed this, again, I'm not a digital mode person, but this is another quick and easy and very low amounts of wiring job. Well, like I said, not every issue has something for everyone. Every issue, I should say, has something for everyone, but not every issue has a really inexpensive, cheap kit. In this month's QST, there's a really great Arduino antenna analyzer, but it takes a lot more effort than these kits I've been showing you. In August, they had a wonderful kit available. 3 stacked handmade wire wrap boards. Look at that parts list. And yet, this is great for if you have the interest in this. You've got a single sideband transmitter for your SDR receiver. So this is a transmitter kit, SSB. Okay. Let's see. There's a schematic, and that was August. In September, I was going to do this for the KX3 till I sold mine, and I'll always regret that.
Sorry. I'm glad Tim's not here.
The KX3 actually had a way to, you can send PSK and some other, I think RIDI too, by using your paddle to send CW, Morse code, into the radio, and it would do the mechanics of turning that into RTTY or PSK 31 or whatever. And this is great, but okay. What Elecraft did with the KX3 then said, okay, we're going to put a USB port in the PAN adapter, so with a keyboard you can actually type characters that'll go out as RTTY or PSK31 or CW. So all of a sudden you don't have to have the ability to, or even understand CW, or have the ability to operate a keyer. Well, does the KX2 have a PAN adapter?
No.
No. Okay, so this was for the KX2. They wanted that same functionality for a KX2. So they could, instead of having to use the paddle to send CW, PSK or RTTY, they wanted a keyboard. And there it is. Again, very, very simple. Up in the upper right, that's it. It's a Arduino Pro microprocessor, a couple of opto isolators, those U1 and U2 up there on the right. And bingo, you've got a way to do the same thing you can with the KX3 PAN adapter now with the KX2. And that was September. Now, this is the one that Tim saw that he wanted me to show. This guy, this ham, thought it would be fun to have a desk clock with accurate time, all these features of the gray line view, locators, beam heading, DX beacons, oh, even a news headline. I haven't turned that on yet. I'm going to go ahead and turn that on here. We'll get up in this in just a second, but I got to turn on RSS feeds. I'm not getting it. Oh well, I'm not getting it. Well, this, if you look at the picture of this thing in this article, that looks beautiful. I mean, you've seen the geochron screens and all this kind of stuff. And in the upper right, that is the total amount of hookups to be made. That's all the wiring you do right there. You buy 3 chips, you buy an enclosure, well not an enclosure, but yeah, an enclosure and a touch screen. It's a resistive touch screen. And put the programs in it. And here's the standalone unit. I'm going to hold this up. Standalone unit with Wi-Fi connection. Right now it's to my hotspot, to my phone, showing UTC time, our time locally, and all kinds of interesting other details, sunspots, sunspot numbers. I've put the temperature module so it'll show me humidity and temperature as well as air pressure in this location. So when I go portable, this is all I need. So it can show my time, UTC time, and you can push on a location. You want to see what the DX time is, and it'll show you that DX time. It'll also show you how to point your beam to get to that. So a very, very capable and full-fledged ham clock that takes all of those 3 parts. Okay, let me.
How much does that cost?
The parts, all the parts cost $150. And that includes the Huzzah. It's a Wi-Fi enabled microprocessor. This thing takes a lot of programming. Since I finally learned how to program the Arduino, because I was doing it for the BitX, I knew what I was doing to put these various include files, libraries, modifying all that. But let's see here, where did it say? Down the very top there, it says, Adafruit Huzzah, Wi-Fi system on a chip for $16. Well, if you want to spend a little bit more money, you can email this guy, Arthur, and he will sell you, with shipping, all included, $31, completely flashed. You don't have to do any of the program loading at all. If you're not used to it, that's a real good deal.
Including your call sign?
No, the call sign you enter yourself. You can enter your call sign, you can change, you can recalibrate the touchpad, and you can change your signal source. At home, I have it in my Wi-Fi network in the home, but right now it's on my cell phone, it's a hotspot. So when you power it up, it gives you that option.
Remember the $5 part that was actually $35?
Yes, there's a $5 part.
Yeah, the magazine says $5.
Yeah.
Controller.
And on his website and others, that has been changed, that's been noted down there. The FPC, well, no, it's the display controller. The second item down is really $35. This is another example of where you have to do it yourself. You have to imagine there was no readily available case or bezel for this display. He found one that was close, and he made it work with super glue, hot glue. It was meant for a type of display that has screw holes in there, but no, he didn't have that. He didn't really mention it in the article either. You had to figure that out. But what you have to do is glue the pieces of the frame together, glue the feet on it, and then affix. He used double-sided tape. If you see on the left, he affixed all the boards to the back of this display with double-sided tape. I went a little bit further and used hot glue. I don't trust it either, but it's working so far. An interesting side feature about this Huzzah chip is that it has a built-in charger circuit for lithium ion. So I put a battery on this thing, and so when I'm at home, I want to charge it up, I hook it up to a USB signal power supply, but it runs off this battery for 5 or 6 hours, plenty of time. And because it's not really, it doesn't have its own oscillator for the time, it is getting the time off the internet, and that time is correct. So I think I did a little bit neater job. I used wire wrapping techniques to make my few wires. He used jumpers. I don't know where he got those, but jumpers just stuck over the pin and he was done. And there's my unit with my call sign up above there. The DE, that's me. I'm an Echo Mike 65. You see that kind of orange dot. And right now I was looking up there somewhere in Russia, the DX, it was 1556 my time, it was 2356 their time. It gives you the longitude, latitude, and all that kind of stuff, and the distance in kilometers. When the sun set, when the sun rises in that location, same with mine. And it also shows the sun and the moon. At the upper right, that's the sunspot, that's the sun, there's no sunspot. The solar flux is 69.1. The primary planetary K index here is 4. UTC is exactly what it says. If you push the button UTC, you can modify that for whatever time you want. And if you somehow lose your Wi-Fi, it'll show that highlighted to let you know you're no longer really sure what the time is. But that was October, and that was one of the finest little kits I made out of here. Any questions on this one before we go further? Good. Okay, now we're at the last month that I had QSTs. This one has a great Arduino-based antenna analyzer project. You go to QRP guys, and this is one of the ones that's big. This is not going to happen overnight, or this is going to take 3 or 4 or 5, 6 days to put together. To say nothing of trying to find where all the parts come from, order all the parts, get them in place, and stuffing the board, soldering the board. The PC board for that is available, but that's not what I call a simple, easy project. What I wanted to show was a simple way to expand the range of your 75 meter, 80 meter dipole, and with a very simple circuit, a controller with some switches and a relay, and then an inductor. If you look in the upper left picture up there, it says you see where the coax is being stretched by a loading coil before going to your half-wave dipole. And then there's the drawing pictorial about how you do it. And of course, a little box there. So that is another what I call a very simple, easy to build project. Thank you. That concludes this portion of your day. Thank you. Thank you. Oh, well, thank you very much. Well, I'm a lumberjack and I'm okay. Work all night and I sleep all day. A beard and glittering eye now, wherefore stops thou me? Okay. It was the best of times. It was mares eat oats and does eat oats and little lambs eat ivy. A kiddle eat ivy too, wouldn't you? Bill Randall, 650. Dorothy, yes ma'am. The Axelwhite and Peppermint Endurance Company in Bashville, Johnny C. Home of the grand old conglomeration, Fanny Hill University, and the bathtub of the South. It's 7:30.